Okay, so in 28.2, we talked about converting from polar coordinates back to rectangular coordinates x, comma, y. And today, this first part is going to focus on doing the exact opposite of that and taking our polar, which is now rectangular coordinates, and transferring them into polar coordinates. Now, this is going to go back to what we talked about a lot this year already with using this picture here, and the fact that if we're given x and y, we can find r and theta by using Pythagorean theorem in trigonometry. Because to get r squared, we need x squared plus y squared, aka r is going to equal the square root of x squared plus y squared. Okay, think back to our good pal, the Pythagorean theorem. Now to find theta, again, we're given x and y, aka the opposite and the adjacent side to theta, so we're going to use tangent. So in our calculators, to find that angle measure, we're going to take tan inverse of y over x. So again, an important reminder here that your calculator is going to restrict your answers for theta to be between negative 90 and 90 degrees, quadrants 1 and what I like to call negative 1. So you always need to make sure you are aware of what quadrant your answer should be coming from so you can adjust it if needed. A good example of that is example A that they provide in the book. If we are given x comma y is at negative 9 square root 3, we have a quadrant 2 value. Okay, and this is important because when we find r, we're typing in x squared and y squared and taking the square root of that. Notice the use of parentheses. We get r to be 18, right? So r equals 18. Now for theta, when we take tan inverse of y over x, we have to be very careful though, because as we type this in the calculator, what you're going to notice here is tan inverse of 9 square root 3 divided by negative 9 gives us an answer of negative 60. That's in quadrant 4. Our answer needs to come from quadrant 2. So if we add 180 degrees to that, that reference angle of 60 shows us that the quadrant 2 theta will be 120, which you'll see is the appropriate answer here for our theta. Okay. Now another example, if you look at example B, 6, negative 8 is going to be in quadrant 4. So we want to double check, does our answer actually fall in quadrant 4 when we look for theta? Now R, again, is found by taking x squared plus y squared. And we type that in, 6 squared plus negative 8 squared is 100, square root of that is 10. And then for theta, tan inverse of y over x, if we take tan inverse of negative 8 over 6, we get negative 53.13. Now, this does in fact fall in quadrant 4. So this is an acceptable answer. If you like your answers to be between 0 and 360, however, feel free to add 160 degrees. Reminder with polar coordinates, they do officially sometimes have more than one answer. So an answer of 10, negative 53.13 is acceptable. Or again, this 306.87 also acceptable because of the fact that these are the same location. Okay. Now, last but not least, if you want to use your calculator like we talked about, using the second apps menu yesterday to get the polars to rectangulars, you can also use options 7 and 8 to convert, 5 and 6 to convert them from rectangular to polar. I highly recommend this when it comes to converting for your theta, because what you're going to notice is it will take into consideration that quadrant. Okay, so it's a nice option as well.